Hey everyone, it's Ben from Board to Bits, and welcome to part 6 of our series on making a custom character controller in Unity. So in our last video we got our access keys struct to look a little bit better in our inspector. Now I want our input manager and our keyboard tracker to actually dynamically work together a little bit better, and so we're going to do that through the use of custom editors. So the first thing we're going to do actually is we're going to create a script or another function inside of our keyboard tracker script. So let's jump over to the project, to our input scripts, keyboard tracker. Actually, we're going to open device tracker as well, because we're going to want to put this into device tracker as a abstract function. So we're going to say void, actually public abstract void. I'm going to call this refresh. And that's all we're going to do in here, because we don't actually have to declare anything because it's an abstract function in here. Inside our keyboard tracker now, we are going to create a actual function for this refresh, give it some code to execute. So I'm going to say public override void refresh. And this is kind of going to be similar to what we did in reset. However, the problem with reset is when you hit reset, it completely wipes out any information you have. Any keys you have stored in there go away, and we don't want that. We want to retain that information. So that's going to be really the purpose of this refresh function for us. So the first thing we're going to do, we're going to get that input manager again. So we're going to say input equals get component input manager. And then we're going to create two kind of temporary arrays for our key code information and our access keys information. So we're going to create two temp arrays for buttons and axes. I'm going to call this key code array. I'm going to call this new buttons equals, and this is going to be a new key code array, and its length is actually going to be based on the input manager's button count, because basically what we're assuming here is either the button count or the axis count has changed in the input manager, so that's where we need to be creating this new array for them. And then likewise, access keys array new axes is going to be equal to new access keys, and again based on the input manager's axis count, which may have been updated at this time. And the reason we're doing all this instead of just putting information right into our old access keys and button keys is that we want to, like I say, retain that old information. And how we're going to do that here is we're going to say if button keys is not null, because like the first time we do this, the first time we put in our keyboard tracker, there's no information in there, so there's no reason to save old information. There's no information to save. But if it's not null, then we need to save that information. So we're going to say for int I equals 0, I is less than, and this might be one of two numbers. This might be the length of our new key code array, or it might be the length of the old key code array. It's whatever's shorter, really, because say we had 5 buttons and now we are cutting it down to 4 buttons. Well, we only need to save those first 4 buttons. Likewise, if we have 5 buttons and now we're increasing it to 7 buttons, well, we only need to care about those first 5 buttons. There's no information for those last 2. So we're going to do this by saying mathf.min, and we're going to check against those 2 numbers. So we're going to check new buttons.length and button keys.length. Whichever's shorter is what we'll use, and we'll just iterate I++. And all we have to do here is say new buttons at index I equals the original button keys at index I. And once we've gone through all of those, now we know that our new buttons array has all the old information it needs. Now we can finally replace it, and we can say button keys equals new buttons. I'm just going to copy all of this for our axes because it's actually going to work the exact same way. It's just going to be, instead, we're going to say if axis keys is not null. New axes dot length is compared with axis keys dot length, and then new axes I equals axis keys I, and finally axis keys can be replaced by the new axes. So again, we're replacing whichever relevant or passing into our new array whichever relevant axis keys exist, and then we're just replacing the old axis keys array with the new one we've created based on the updated input manager. So that's all we're doing in this refresh function. We can actually, we could get rid of the reset function. I'm going to keep it there just because if we do happen to hit reset, I like making sure that our keys are still the proper lengths, or our arrays are the proper lengths. But we'll save that, and now we need to actually create our custom editors that are going to call on this refresh function. So in order to do that, we need to jump back over to Unity, go into our editor script, and we need to create two new scripts here. The first one's going to be an input manager editor, and the second one is going to be our keyboard tracker editor. We can open these up in MonoDevelop. Input manager editor, keyboard tracker editor. We're going to start with the input manager. And how this is going to work, we're actually not really going to change the appearance of the editor in this case. However, we want to change the functionality around it. What we want to do is say, hey, if something's been changed in either our axis count or our button count, we need to refresh the device, whatever relevant device tracker is there. So we can do that pretty easily here. Now the function, if you recall in the last video, when we're drawing a new property, it uses the function onGUI. This uses something similar, but it's called onInspectorGUI. So we're going to say public override void onInspectorGUI. Actually, I should have done this before all this, but we need to replace using system collections with using Unity editor. And instead of inheriting from monobehavior, this is going to inherit from editor. And lastly, we're going to put in an attribute here saying this is a custom editor for our input manager. So custom editor type of parenthesis input manager. And so all of this says, once again, when Unity sees an input manager in our inspector, it should go to this, this script and use the function here to tell it what to do. So right now, because we're overriding, we have nothing here, what we'll see in our input manager is that nothing appears at all, because we're not telling it to do, once again, we're not telling it to do anything. In the same way that the axis keys were saying no GUI information, there's just nothing to draw. We can put back what we had originally simply by saying base, oops, to indent that, base dot onInspectorGUI, and that basically goes back to the default GUI and says, oh, what should this be? So if we look here now, we'll see we're doing the exact same thing we were doing originally. But in addition to this, I want to take a look and check and see, are we changing anything? And how we do that is with a very handy couple of functions called editor GUI dot begin change check. Doesn't take any parameters, but basically this kind of starts a section of your code that it's specifically looking, has anything changed within this section of code. And then after we put in our base inspector, we can say if editor GUI dot end change check, and you notice this returns a bool. So basically what happens here is that if anything inside of here let me break this up a bit. If anything within here, between begin and end, changes, then this will return true. So therefore, if true, we're going to do something here. Do something. If nothing has changed in here, then don't worry about it. Just skip on to the end. What we're going to do in here is we are going to call that refresh from our device tracker. We're going to call this refresh. And how we're going to do that is we're going to say up here, we need to somehow get to our input manager and get to that get to the device tracker from the input manager. And how we're going to do that is we're going to say up here at the start of all this, we're going to say input manager IM equals target as input manager. And what all this means is we're creating this variable IM, and what it's getting is target. And what target is whatever target refers to whatever the inspector is currently drawing. So right now the inspector is currently drawing some input manager, so target literally is this input manager. This is our target. And but we do have to cast it as an input manager, because when you just get target, it's really just I believe it's just an object. Yeah, it's just the object that it's working with. So with all that done, we can now in here say IM dot. Now we can't call on this refresh function because we don't we don't actually have a reference to the device tracker. So what we're going to do is we're going to create a little helper function. So we're going to say refresh tracker, and in our input manager, I'm going to create this function. So I'm going to say public void refresh tracker. And what this is going to do here is it's going to check if there is a device tracker to be used. So I'm going to do that by saying device tracker dt equals get component device tracker. So if a device tracker exists on this object, we'll get it here. And then we can say if dt does not equal null, meaning there is a device tracker here. If there's none here, don't bother doing anything. Then we can tell it to refresh. So with all of that done, now our input manager knows we're going to get the input manager, we're going to start checking for changes. If changes happen inside of here, then we can refresh the tracker that's tied in. So what we should see here now is if I save this, if I grab onto, say, this axis count and pull it up, we see that we start adding axes for every time I increment it up one. Likewise, I can go back and drop back. Now it is worth noting if you go below the number, you will lose that information. So if I drop this from this button count from 3 down to 2 and then go back up, it now appears as none again, because how we're refreshing this, it remembers the key code until it's done refreshing, and then it's just that information's gone. So that will still wipe away that information. However, this is a lot better than before, where if I changed this, I would have to increase it and then go right click and reset, and we'd lose all the information. So we'll bring this back down to 3, set this back as X, save that. But that's all working for us now, and that's pretty good. Now the other thing I want to do while we're changing all this is I want to look at our keyboard tracker, because while this is better, it's still kind of messy and clunky here, and we could actually change the size of these arrays, which would then make this not align, and we really don't want all that. So we're going to change our keyboard tracker editor as well a bit. Again, first thing we need to do is change our namespaces up here, because we want Unity Editor, but we don't need System Collections. Going to add that attribute custom editor type of keyboard tracker, and we're going to make sure this inherits from editor. And now what we can do in here again is create a new public override void on inspector GUI. And inside of this function, we're going to get our keyboard input because we're going to need information from it. We're going to need to kind of tell this function what it should be showing, and so we're going to need access to our keyboard tracker class. So we're going to say keyboard tracker KT equals, and we're going to use the target again, target as keyboard tracker this time. And now we're going to start, instead of using, like here we use this base, which just basically use the default inspector, we're going to create this whole inspector from scratch. So the first thing we're going to do is we're going to create a label. We kind of have it here, like this label for our axes. Whoops. For some reason, sometimes when you change the GUI information, it will yell at you for doing multi-object editing, even though you're not. I don't really know why. It just kind of happens. So, well, we lost it here, but we know we had a label for axis and then the axis array and the label for buttons in the button array. We want to kind of keep that idea, but we're going to do it a little bit nicer this time. So I'm going to say editor GUI layout dot label field, and so this creates just what it sounds like. And we're going to call this label buttons. Actually, we'll do, what's the order we have it here? We have axes first. We'll start with axes. Axes, and we're going to want to bold this so that we know it's a nice, strong header at the top of this. So we're going to say editor styles dot bold label. Next thing we're going to do, we're going to indent this one level. So we're going to say editor GUI dot indent level ++. Now you'll notice that this one uses editor GUI layout, this one uses editor GUI. There's not really a strong rhyme or reason as to why these use different things like this. Typically it's basically that editor GUI layout are kind of helper functions like this that makes a label for you quickly and easily, whereas editor GUI is kind of the raw functions or the raw information, but it's just kind of a thing you have to know by doing it. So from here we're going to say if ki dot axis, no, why isn't, oh, if kt, sorry, dot axis keys dot length equals 0, so if there's no information, we don't actually want to list out axes. And instead what we're going to do, we're just going to put in a editor GUI layout help box. And this is going to say no axes defined in input manager. So it's basically going to tell us, oops, not dot length. It's going to tell us there's no, there are no axes for us to show, and instead of just not showing anything, we'll kind of give a reason why. And we're going to give this a message type we'll just do .info. It's not really a problem. Your game might not have axes for some reason. We're just explaining why we're not showing anything. Otherwise, if there is axis information to be shown, then we're going to check that axis information by saying serialized property prop equals serialized object dot find property, oops, axis keys. And what all of this is basically doing is going through the process of getting us this array. Because we're again using kind of a custom struct, we need to do it in this way, and because it's an array, that gets us this information and brings it from the keyboard tracker into the keyboard tracker editor. Now that we have that, we can say for int I equals 0, I is less than ki dot axis kt dot axis keys dot length I plus plus. And now we can say editor GUI layout and put in a property field and give it the property get array element at index. This is why we created that serialized property, is because it lets us actually get array elements at I. And we're going to give it a new GUI content. We're going to actually give it a custom label. Instead of saying element 1, element 2, element 3, we're actually going to say axis, make sure you include a space there, plus I. So instead of saying element 1, element 2, element 3, so on and so forth, it's actually not, there we go. It's going to say axis 1, axis 2, axis 3. This actually should potentially work now. Let's see if this is working in our... Yeah, and it appears now. So we have axes. These do not indent because we had actually set up the axes not to indent, because of how we set up our property drawer. But then those both appear, and they're being called axis 0, axis 1. And then we're going to say editor GUI dot indent level minus minus, because technically speaking, we might again want to figure out later on if we did want these to indent, they could do that there. Now we can do basically the same entire idea, but for our buttons. These work a little bit differently because the buttons are a drop-down, just a simple drop-down, so they don't need this special serialized property, but we'll build this out again here. So we're going to say, first off, editor GUI layout dot label field, this time for our buttons. Buttons, editor styles dot bold label. So that creates that header for us. Editor GUI dot indent level plus plus. And now if kt dot button keys dot length equals 0. I'm actually going to copy this part here because it's a little bit long and it does the exact same thing. But we can just say no buttons defined in input manager. Else, if there are buttons, then what we do in this case is we say for int I equals 0, I is less than kt.buttonkeys.length, I plus plus. And here we can say ki.buttonkeys at index I equals, actually we'll start this here. We're editor GUI layout dot enum popup, because key codes are basically an enum. Oh, whoops, not ki. Apologize. A previous version of this I had the keyboard tracker as like keyboard input, and that's why I keep on writing ki in there. Enum popup, and we're going to give it the label button, button space plus I, kind of similar to what we did with the axes, and kt.buttonkeys, it's going to make appear that same button keys at I. So what this basically does is says, if we change something in the enum popup for buttons at I should reflect that. And the only other thing we have to do here is we actually have to cast this This is actually going to get us a, I believe it's going to return an int, if I'm not mistaken. System enum pop-up, it creates an enum pop-up. I'm pretty sure it returns an int for us, and so instead what we're going to want is to cast that as a key code, because the information at this particular index is a key code. So we'll save all that, and now we should have that appearing up here too. Yep, now we have our buttons. We see that this is actually indenting the way that we intended it to, and we get that information there. And so now we have it where it reflects again. As we add them, they appear. As we remove them, they disappear. Like I say, if we reduce it down lower, we do lose that information. But it's a much kind of smoother system here. And again, we don't have that array length field that we could suddenly be changing these lengths when we don't want them to be changed. Now actually, to be honest, because we have this bold, we don't really need those indents. I'm going to get rid of those in both of these because they're not really doing anything for us. There is one last thing we want to do in here, which is just to kind of make sure that the information is saved properly. We're going to say serialized object dot apply modifier properties, and then serialized object dot update. And basically what that does is says if we change information in here, we want to actually store that information and make sure it is saved, because sometimes what can happen is you'll change, you know, one of your keys, start playing the game, or, you know, go to something else, and that information doesn't get saved unless you tell it to do so with these functions here. So that's all kind of a deep dive into custom editors. We can save this now, jump over, and we see those indents reverted back, so now this is all kind of lined up, but I think it looks good. We have our axes and our buttons labeled properly, and everything seems to be working. So now that we've got this set up so that we can easily edit it and change it as we need to, and we don't have to worry about changing things and creating a mismatch like we had before, we can dive back into our actual character controller in the next video and look at how now hitting these buttons is going to inform the input manager, which is then going to inform our character how it should be moving and interacting with the world. So thanks for watching, and I'll see you in the next video.